Section 12.3 talks about additional constructions. So here it says students will be able to understand and explain how to construct parallel lines, angle bisectors, and perpendicular lines, and some information about angle bisector properties. Okay, so let's take a look here. We have how to construct parallel lines. So it says to construct a line through P parallel to L, make P a vertex of the rhombus so that one of its sides is on L. We're going to draw a point through P, any line that intersects L at the point A. This will be one side of the rhombus. Then we're going to draw an arc with a pointer at A and radius AP to mark the third vertex X of the desired rhombus. With the same opening of the compass, we're going to draw intersecting arcs first with a pointer at P and then with a pointer at X to find Y, the fourth vertex of the rhombus. And then we're going to draw line PY, and line PY and L is a rhombus. So we got our rhombus right here, okay? So there's another way we can do this using something called the corresponding angle method. So we're going to construct a line through P parallel to L. So through P, we're going to draw a line that intersects. Okay, so we're just going to draw that line right there. We're going to copy the angle alpha at a point P to form corresponding angles PQ at parallel to line L. So this angle here is corresponding to this one right here. Okay. Constructing angle bisectors. It says to bisect a given angle, we make angle A of an angle of a rhombus. With the pointer at A, we're going to draw any arc intersecting the angle at B and C, giving 3 vertices of the desired rhombus. We're now going to draw an arc, we're now going to draw an arc with the center at B and radius AB. Then we're going to draw an arc with a center at C and radius AB. The arcs intersect D, the fourth vertex of the rhombus. Connect A with D, and ray AD is the angle bisector of A in rhombus ABCD. All right, constructing perpendicular lines. It says constructing a perpendicular line to a point not on the line. Okay, so to construct a perpendicular line to L through P, we make P a vertex of a rhombus. We're now going to draw an arc with a center at P that intersects the line at 2 points A and B, 2 more vertices of the rhombus. With the same compass opening, we're going to make 2 intersecting arcs, one with the center at A and one with the center at B. The arcs intersect at Q, the final vertex of the rhombus PAQB. We're going to connect P with Q. Line PQ is the required line, and line segment PQ and line segment AB are perpendicular diagonals in the rhombus PAQR. So how do we bisect a line segment? We're going to construct a perpendicular bisector of AB. We make A and B endpoints of the diagonal of the rhombus. We're going to draw 2 intersecting arcs of the same radius, one with a center at A and one with a center at B, to determine CD, the other diagonal of the rhombus. The line CD connecting the points of intersection in the arcs is a required line. The point M is the midpoint of AB, of line segment AB. CD is the perpendicular bisector of line segment AB. Given triangle ABC, construct an altitude from vertex A. It says an altitude is the segment perpendicular from the vertex containing the opposite side of the triangle. So construct a perpendicular from point A to the line containing line segment BC. Given triangle ABC, construct an altitude from vertex A. Notice that the altitude, line segment AD, does not intersect the interior of the triangle ABC. Given triangle ABC, construct an altitude from vertex A. Since triangle ABC is a right triangle, the vertex The altitude from vertex A is the side line segment AB. Okay, so let's see. Properties of angle bisectors. Any point P on an angle bisector is equidistant from the sides of the angle. Any point that is equidistant from the sides of the angle is the angle bisector of the angle. Okay. So it says draw obtuse angle XYZ. Okay, so remember, we're looking for an obtuse angle. An obtuse angle is more than 90 but less than 180. So this will be my first or my choice, okay, because that's the one that's greater than 90 but smaller than 180, right? All right, so then that says, what's the first step? So we want to put our vertex, our compass point on the vertex Q. And we're going to draw an arc that intersects the lines or the sides of angle XQZ. So we're going to select B. The second step is we're now going to put the compass on point A and draw an arc. With the same compass setting, place a compass on point B and draw an arc that intersects the first. So for the next one, we're going to choose A. Okay. And so now we're going to draw the lines, or the ray, I'm sorry, QC. And this will be our angle bisector. Okay. So it says, construction companies avoid vandalism at night by hanging expensive pieces of equipment from the boom on a crane. If you consider the triangle with two vertices A and B as marked in the figure, and the intersection of the line through the cable holding the equipment to the ground as the third vertex, what kind of triangle is formed? Okay, so let's take a look here. So we're going to take a line through the cable holding the equipment and the ground. So now we're looking, oops, my line got a little crooked. Okay, so now we're looking at this triangle here. And it says, so this angle, this triangle right here. What kind of triangle do we have? We're going to have a right triangle, okay? And then part B says, if you consider the triangle formed by points A, B, and C, describe where the altitude containing vertex A of the angle is. So this altitude right here is going to be the extension of the ground, of the cable the extension of the cable from vertex A to the ground, right? Okay. So let's take a look at the next problem here. And I'm going to see if I can zoom in a little bit so I can see that just a little bit better. Give me one quick second and let me zoom in. I know it's probably going to throw me off. Yes, it did, but we will come back to it. Okay. We got to just scroll up a little bit and we'll get back to where we was. Okay, here we go. All right, so we're trying to find the value of x, okay? So what I want you to notice here, if I kind of zoom in on this piece right here, x appears to be this value right here, right? So if I were just to look at that line segment, right? And we know that we have something that looks like this, and it says that 7, and we have something that looks like this, and we know that's 7, and this is my x right here, okay? Well, we know that the whole piece is going to add up to 10. So I know that this whole piece here adds up to 10, right? So wouldn't this piece here have to be 3? And this piece here would also have to be 3? So if I kind of look at what I have here, I have this piece here, and this piece here, and this value I know is 3, and this value I know is x, and this value I know is 3. So that tells me that 3 plus x plus 3 has to add up to 10. So 3 and 3 is going to give me 6. So x plus 6 has to add up to 10. And if we subtract 6 on both sides, we end up with x is equal to 4. Okay. So the next problem says some car jacks are constructed like a collapsed rhombus. When used to raise a car, the rhombus is easily seen. If the sides of the rhombus are 22 inches, what's the maximum length of the shaft? Okay, so let's think about this way. It's telling me that this piece here is 22 inches, and this piece here is 22 inches. So I want you to think about if the car was right here on top, okay, and that car is pushing its weight downward, then this is going to start flattening out, and this is going to start flattening out. And we know that the total distance from here to here is 22, and the total distance from here is 22. Then the whole thing could not be more than 44 inches, right? Okay. All right, the next problem here says, copy the line segment AB shown and bisect it. Remember what bisect it means. Bisect it means to cut it in half. Well, that's the one that's cut in half. Okay. All right, so guys, we're going to skip this next problem here, but I am going to go to this one here. Okay. And it says in the figure, the measure of angle A is 50 degrees. Explain how to construct a 20-degree angle using this figure. So let's go ahead and do. Okay, so what we're going to do is we're going to construct a perpendicular right here. Line segment, oh, I don't know, let's call it AP. Okay. At point A, this angle formed is going to be, because it is perpendicular, it's going to be the complement, right? Because remember, complementary angles add up to 90 degrees. So if this angle here is 50 degrees, and I know that the whole angle here is going to be 90, then this angle here would have to be 40 degrees. And then if we bisect that angle, then the construction is going to be complete. Okay? All right. So it says lines M and N intersect as shown to form two vertical angles. Lines P and Q bisect the vertical angles. Explain why P and Q are perpendicular. Okay. So let's see. It says, so if we know that we have vertical angles here, right? These are bisecting the vertical angles. Then choice B will be my answer, because it says the sum of the angles formed by M and P, so this angle right here, P and N, this angle right here, and in Q, this angle right here, and Q and M, this angle right here, that has to add up to 180 degrees since it's a straight angle. And then it says, since the angles formed by M and P, so this angle here, and P and N, this angle here, are going to be equal, and also the angles formed by N and Q, so this angle here, and Q and M, Q and M, this angle here, are equal, then the sum of the angles formed by P and N and Q equals 90 degrees, and so the lines are going to be perpendicular. Okay? All right. So the next problem here says, in the following figure, line segment AB is parallel to line segment ED. Okay, so we know that this line segment is parallel to this one right here. And we know that line segment BC is congruent to line segment CE. Explain why DE which is, let me get my pen going again. Oh, come on, don't freeze up on me. Here we go. Line segment DE and AB are going to be the same. Okay, going to have the same measure. So let's take a look. What do we know here? We know that this angle is the same as this one because they're vertical angles. And we know that this segment here is congruent to that segment. That means that they have the same measurement. We would also know, because these are parallel, then we have alternate interior angles. And alternate interior angles have the same measure. So we know that these triangles are be congruent by angle, side, angle. Angle, side, angle. So I'm going to look for angle, side, angle. It's part C. And then corresponding parts of congruent triangles are congruent, since the line segments are congruent. AB is equal to DE because of the angle, side, angle, right? And that was 12.3.